Hello everyone, this is Lucas coming at you today with a quick hack I did with a 3M TR800 positive pressure filter mask. This is used for asbestos removal and weird stuff like that, where you need a positive pressure mask and constant air filtration, but not necessarily your own gas. So yeah, this is used in the asbestos industry and other places like that, where you want to have a positive pressure in your mask, but you don't necessarily need your own air. I chose this today for my experiment because what I'm trying to do is build a breathing assist machine. I just wanted to see if it was possible to control the fan motor on this mask with a standard Arduino and 5-volt relay board. And you can see them down there. I have them hot glued to this piece of cardboard. Very high tech. If you look at my wiring configuration here, you'll see I have the input 2 hooked up through here onto pin 5, which is right here. I also have the ground and the VCC 5-volt from the other side to control the relay. I have cut the hot connection here in the 5-volt, or sorry, the TR800 on the hot side of the 5-volt relay, and I have it hooked into the common and the normally closed. And I twisted the two common wires together on the DC circuit for the TR800. And it's a very simple circuit. I got both of these on Amazon for really cheap. I think I got $10 I paid for both of these. I think the shipping was more than the actual devices on these. This relay board here is the 5-volt DC control side, and it'll do up to 250 volts at 10 amp AC. I would never put that into this relay board though. I only have 12-volt hooked up to it right now, and 12-volt isn't even the proper, it's not the proper amperage or voltage for this mask. I just did this for experimentation purposes, so if you do decide to make your own in the future, you probably want to use a proper voltage adapter for the 3M mask, but I don't even know where the battery is for this thing, and I just wanted to see if it could work. After I got everything wired in and I tested all the relays, made everything work, and made sure I wasn't going to blow anything up. I like to do my Arduino work in steps, where I just slowly work through each one of the steps and make sure everything's working before I connect any of the high voltage stuff on the high side of the relay. That's the last thing I do. I make sure that the program's running smoothly before I connect the relay board, and then I make sure the relay board is clicking properly before I connect the high side, and then yeah, after that, you're golden, I guess. So I wrote a simple Arduino sketch here, which I call Breathe 1. I have an int at the top, which I call Breathe, and I set that to pin 5. A void setup, you can see I set my pin mode for my Breathe to be an output. And in the void loop, I just set a forever for loop in starting off the program with a delay of 2 seconds. So this doesn't breathe in right away. It always waits 2 seconds before it does the first digital write, which is breathe high. So it'll turn on the fan for 2 seconds on a 2-second delay, and then it will breathe low, which will turn the fan off for 2 seconds, and then as you can see the loop, it'll loop back up again and wait the 2 seconds. So we'll always have 2 seconds. I have my son here actually built this with me this morning, but he's too young for YouTube. So, but he tested it out with the mask on. It doesn't work great. Like, I'd never put my life in the hands of this thing, but I mean, given how thin stretched everything is with like breathing machines and all this kind of stuff, this could be a viable option for some people. I mean, if you're screwed, you're screwed. I mean, if it's all you got, it's all you got, I guess. But I mean, at least as an option, and I just wanted to show people out there what is possible for breathing machines. Like, this is not a ventilator, and this is not medical equipment or anything like that. This is just an experiment showing you what's possible. One thing that I noticed, if I could make any adjustments on this, is to plug these vent holes on the side for your breath exhale. This system would work a lot better if it was just the fan sealed into the unit, pushing air directly into the face mask without any of the exhalation ports. Right now, you're not getting the full blast of the fan inside it, but it does push air inside of that mask. And it does supply with air. So even when I'm not breathing and have the mask on and I'm just letting it do its thing with the fan on, I'm noticing that it is forcing a little bit of air into my lungs. But then again, like I said, if you plugged all the ports and only have the fan blasting in and then just, relied on back pressure for your exhale, I think this could actually work quite competently as long as your airway is open, which may not always be possible. But like I said, this isn't a medical device. This is just a science experiment. So with that, I'm going to go into the program here. And I always like to keep an empty program open when I do Arduino. And you see there, I just have an empty program. And this is my off switch. So what I'll do is that I always make sure I have an empty program loaded into my Arduino whenever I'm working on it or doing anything. And then that way I'm sure there's no voltage going to any of the pins or anything like that. I don't blow anything up. So right now I'm just sitting on an empty program. So now I'll go to the program that I just wrote, and we'll upload it, and you can hear the workings of the machine. Give it a second here. And it likes the program. Here we go. And as you can see, and Arduinos are little dynamos. This thing will just keep doing this until it fries the motor or the relay. And yeah. So again, this is Lucas. If you like this video, give us a thumbs up and subscribe. If you make another breathing machine of yourself that's on Arduino, hey, please upload it. The world needs it right now. Maybe you'll give somebody some inspiration to build something really cool and easy to keep people alive. It just keeps going. All right, take care.